Episode 3, The First Moment. What if we could rewind the universe? Not by years, not by centuries, not even by millions of years. Imagine rewinding everything, every galaxy, every star, every planet, every atom, every moment of history backward, back before humanity, back before Earth, back before the sun, back before the first stars lit up the darkness. Keep going, farther, farther. And eventually, something extraordinary begins to happen. The universe starts to shrink. Galaxies move closer together. Space itself contracts, temperatures rise, matter becomes denser. The cosmos grows younger and younger and younger, until we arrive at a moment unlike any other, a moment when everything we know and everything that has ever existed was compressed into a state beyond human imagination. This is where our story begins, or at least, this is where we think it begins. Nearly 8 billion years ago, the birth of the universe, the event we call the Big Bang. But before we go any further, we need to clear up one of the biggest misconceptions in science. Most people imagine the Big Bang as an enormous explosion, a blast erupting into an empty void, a cosmic bomb detonating in darkness. But that picture is wrong. The Big Bang did not happen inside space. The Big Bang created space. It did not happen at a location. It created locations. It did not occur at a time. It created time itself. This is where things become difficult for the human mind, because every experience you've ever had exists within space and time. You have never experienced reality without them. Yet when we travel back to the beginning of the universe, space and time themselves seem to emerge from the event, which leads to one of the most famous questions ever asked. What happened before the Big Bang? At first, the question sounds perfectly reasonable. But many physicists would argue that it may not make sense at all, because the word before requires time. And if time itself began with the Big Bang, then asking what happened before it may be like asking, what is north of the North Pole? The question assumes something that may not exist. This is one of the strangest ideas modern science has ever encountered. The beginning of the universe may also be the beginning of time itself. Not the beginning of things within time, the beginning of time. Pause for a moment and think about that. Every memory, every event, every sunrise, every civilization, every life, every star, everything that has ever happened, exists within a timeline that may have started at that moment. The universe is not simply old, it may be the source of age itself. Now let's continue our journey, closer to the beginning, closer than any human being can truly imagine. As we approach the first fraction of a second after the Big Bang, our understanding begins to break down. Physics starts to lose its footing. Our equations become uncertain. Our theories grow incomplete, because we enter a realm known as the Planck epoch, the earliest known chapter in cosmic history, a period so extreme that the laws of nature we use today may no longer apply. Temperatures were unimaginable, densities beyond comprehension, conditions so alien that our best theories struggle to describe them. This is one of the greatest frontiers in science, a place where our knowledge fades into mystery. Yet shortly afterward, something astonishing may have occurred, something that changed the fate of the cosmos forever, an event known as cosmic inflation. If inflation happened, it was one of the most dramatic events in the history of existence. Imagine something smaller than a single atom. Now imagine that tiny region expanding faster than the speed of light, growing from microscopic to astronomical in an instant, not over centuries, not over years, not even over seconds, but in a fraction of a fraction of a fraction of a second. Universe exploded outward in size, a burst of growth so violent that it transformed reality itself. This idea may sound impossible, and yet many observations of the cosmos point toward exactly this scenario. The remarkable smoothness of the universe, the structure of galaxies, the patterns found in ancient radiation, all of them suggest that something extraordinary happened in those first moments, something that stretched the newborn cosmos beyond imagination. And then, the expansion slowed. Not completely. The universe continued growing, but the explosive inflationary phase came to an end. What remained was a universe filled with energy, a brilliant ocean of particles and radiation, a universe hotter than the core of any star. At that stage, atoms could not exist. Matter as we know it could not survive. Everything was too energetic, too chaotic, too young, but the universe was expanding, and expansion causes cooling. Slowly, the cosmic fire began to fade, minute by minute, year by year, century by century. The universe cooled enough for the first particles to combine. The first atomic nuclei formed. Hydrogen emerged. Helium emerged. The ingredients of future stars were born, yet something remarkable was still missing. Light, or rather, light that could travel freely. For hundreds of thousands of years, the universe remained filled with a dense fog of charged particles. Photons could not move very far. They were constantly scattered. The cosmos was opaque, like a vast glowing cloud. Then came one of the most important moments in cosmic history. The universe cooled enough for electrons and atomic nuclei to combine. The fog lifted. For the first time, light was free to travel. And some of that ancient light is still moving through the universe today. Right now, through your room, through your body, through our galaxy. It is called the cosmic microwave background, the oldest light humanity has ever observed, a fossil from the infancy of the universe, a message sent nearly 8 billion years ago. When scientists detect this ancient radiation, they are seeing the earliest image of the cosmos ever captured, not by a camera, but by reality itself, a baby picture of the universe, and what a picture it is. At that time, there were no planets, no stars, no galaxies, no life, no Earth, no oceans, no mountains, no civilizations. Only a young universe waiting to become something greater. Then came darkness, not because the universe was empty, but because stars had not yet formed. For millions of years, enormous clouds of gas drifted through space. Gravity slowly gathered matter together, pulling, shaping, building, patiently preparing the next chapter. And eventually, the darkness ended. The first stars ignited. The first cosmic lighthouses pierced the night. The first generation of stellar giants illuminated the universe. These stars were unlike most stars we see today. Many were enormous, hotter, brighter, short-lived. They lived fast and died violently. But in their deaths, they created something extraordinary, the elements that would make life possible: carbon, oxygen, iron, calcium. The building blocks of planets, the building blocks of biology, the building blocks of you. Every atom in your body has a story. The iron in your blood was forged in a dying star. The oxygen in your lungs was created deep inside a stellar furnace. The calcium in your bones was born in an ancient cosmic explosion. In a very real sense, you are made of stardust, not metaphorically, literally. The atoms inside you were created long before Earth existed, long before humanity existed, long before anyone could look up and wonder where they came from. And perhaps that is the most beautiful part of this story, because the universe did not merely create stars. It created observers. It created beings capable of asking questions, beings capable of looking back across billions of years and wondering how everything began. The universe became aware of itself through us. And yet, after all we have learned, one mystery remains. Was the Big Bang truly the beginning, or merely the beginning of our chapter? Could there have been something before it? Another universe, another reality, a deeper layer of existence waiting beyond our understanding? Today, no one knows. And that uncertainty is not a weakness. It is an invitation. An invitation to keep searching. Because every time humanity reaches what appears to be the edge of knowledge, we discover another horizon waiting beyond it. And in the next chapter of our journey, we'll encounter something just as mysterious. Something that may outweigh every star, every planet, and every galaxy we can see. A hidden substance that shapes the structure of the cosmos itself. Something invisible, something powerful, something we still cannot explain. Dark matter.